this and we'll save it up. Computers and computer systems, week 2. So a woman was the first programmer, apparently. Ada Lovelace. She was like, I think she was related to the lady who wrote the Frankenstein story. Anyways, she used the computer. When I say computer, it was not an electronic computer that we're used to using. It was a mechanical computer. So kind of when I say mechanical computer, you might have heard, the nearest thing you might have seen to it is people used to have these wind up jewelry boxes. You'd wind up this key and you open the jewelry box and make a music. Yeah, you seen those? Yeah, music box. But I mean, it doesn't lean on electricity. You just wind it up like a clock, and it would make music, and things would turn around. So the music that it would make would be by little bits of metal poking out on a cylinder that sort of go against sort of other bits of metal that hang down against it. And so that was a machine. So Babbage had 2 machines he made, an analytical engine and a difference engine. And they were computers that didn't have any electricity. So they just had sort of rotating columns with gears on them. Yes, gears. And based on their movement, you could get calculations like adding, dividing, multiplying, etc. Now that machine came into that machine was known to Ada Lovelace, and she sort of came up with some way of using it, I guess you could say. So that's the analytical engine that they're talking about there. Now, in this lesson, we want to talk about computer hardware. That diagram there is computer hardware as we have known it for the last 40 years. So what I mean is if we were having this lesson 40 years ago in 1982, people would look at that and they would recognize almost everything in there, except maybe that printer, because that printer seems to be a laser printer. But yeah, most of that other stuff has been around for like 40 years. And certainly that the output device they've got there, which is screen, that's a CRT or the old type, like the old TVs, as opposed to the flat screens that everybody has now. The system unit, we still do that. And you'll find a system unit underneath your desk. That's where the motherboard and all the main components of the computer are. These other parts we call peripherals. So let's talk about that. What is a computer? Computers can be programmed. Even the simplest computers can be programmed. Some of them just have one program in it, like a watch, a quartz watch. Now, when I said that, I say that carefully because nowadays watches can be quite complicated. They're almost like a mobile phone, some people's watches. But I mean, if you take the very simple quartz watches that have also been around for like 40 years, they will have a small computer program in them, which just sort of keeps time. So those watches can't be programmed by the user. They were programmed by an engineer. But some of you would have watches that you could program quite possibly, and programmable calculators, and of course anything else. Now you can run computer programs on your phone. You can download certain compilers and write programs that would run on your phone. I found a few years ago I was using a bunch of tools that would allow you to write web pages, create web pages on your phone. So you can do that. So the 5 basic operations of computer programming we are going to talk about, or not just computer programming, what happens in a computer. This IPOS cycle, we're going to look at each one of those things, input, processing, output, and storage. And we're going to look at each of those in the next couple of slides, I guess. So input is obviously entering data. We think of that as a person doing that. So that could be you talking to a computer, because you can do that now. It could be you typing something in. It could be also you having some data in a storage device and uploading it into the computer from the storage device. Processing, that's going to happen because you have you have various processors in your computer. We think of mainly of the central processing unit, the CPU. That's where your programs are going to be run. Output. So you're looking at computer output now, which is coming to you via that screen. That's your most common computer output, I suppose. Sometimes we like what we call a hard copy. Then you got to have a printer. And storage. Storage would be the thing about the storage. It should be a little bit more permanent. So what I mean is what I'm doing on the computer now, it's very nice. We're looking at it here, but once I turn off the computer, all of this is gone unless I've stored it somewhere. In fact, this file, this is a file. This is a PowerPoint slide deck. And so this file is saved on a space on the hard drive. And so that's what we mean by storage. Lastly, there's communications. Very, very big thing in computing, of course, is communications. So that's why IT is what they first called it, information technology, right? That was used a lot in the 1970s, 80s, and then they started calling it ICT, which is information communication technologies. And so that's the reason why I mentioned that is because that's pretty much recognized. Our computing is not just sort of calculating and crunching things. Communications is a very big part of it. Telephone companies take a large number of computer graduates, and you'll find there's good jobs in telephone companies for computing people because they do a lot of computing, right? Their business is computing. You might say, oh, well, it's phones, right? Well, the phones are computers, and the network is run by computers. And so they have a lot of engineers and computing engineers, communications engineers, almost the same thing, I guess you could say in some ways. But I've come to the end of the slides. Really? I guess. Oh, or else PowerPoint's not responding. Oops. I didn't know it was that. Yeah, we haven't finished. There we go. So there's a video. I'm not going to show you a video in class. I'm kind of philosophically opposed to that because you can watch that video in your own time, unless you really want to. So there's a video there for you guys to watch about input, output, and storage, etc. Please do go and watch it. As I said, I don't think I add any value to a video. So have we covered everything there? Yeah, except the video. No, we haven't covered everything. There's like 40 slides. So what the heck happened there? Let's go to the slide after the video, and we'll continue on there. So yeah, please go and watch that video. As I said, I don't really show videos in class. You can do that. So the idea of data and information. What I like to think of that, now my definition is not exactly the same as this one, but yeah, near. So when you add value to data, then you get information. That's my definition of it. And so that requires processing. So that's why we think of input, processing, output. So I would like to think of it. That's my way of thinking of it. So your input is going to be data. Your output is going to be information. Information actually has a definition. You might be interested, probably you're not, but my master's degree is in accounting. And so I studied a bit of accounting, including the theory of accounting. And the theory of the accounting, they talk about a definition of information. And according to the accountants, at least in Australia, information must be useful for decision making. So information, and we refer to accounting systems as information systems. That might not surprise you. But information systems are useful for decision making, according to the Accounting Society. So what do we do to the data to make it useful for decision making? That is our processing, right? So we can sort it, we can calculate with it, we can put it into a report format. There's lots of things that we can do to take raw data, as it refers to, and make it so that eventually it's useful for decision making. That would then be information. Does that make sense? That would be my way of looking at it. All right, so this is trying to show that example. Here we have some data which is definitely not useful for decision making. It's just a bunch of dates, but, or as it's described here, as unorganized facts. It doesn't provide any context. It's not useful for anybody to make any decisions. Now, this one, on the other hand, might be useful for decision making, because you could look at that and you could say, well, I probably won't go to work on February the 8th, on May the 2nd, July the 9th, or December. That would be useful to decision making, right? We won't put on our shirt and tie and head off to the office because we'll be doing something else. Does that make sense? That is definitely information which would be useful. So data is raw, unorganized. Now, as I said, things that you can do to make it useful could be just as simple as sorting it and classifying it, extracting from it, making a report. And really, you know, as I said, computing's been around for like 50 years, not days, 50 years. Computer programmers back in the 70s and even in the 80s, they might spend all day writing programs to make a report. You know, somebody would say, can I get this report? And all of their data is on the mainframe computer storage. They'd have to write a special report special program just to get a report. Nowadays, you know, you've got your data, you can extract it quickly, put it into Excel. You know, ordinary users can do a lot of the things that programmers would spend a lot of time on in the 1980s. So yeah, what is inside the system unit? The system unit's that box that we're referring to here, right? In our case here, the boxes are quite small, and that doesn't mean that they're not powerful. It's because we have had a lot of miniaturization. So, I mean, here's a big one here, and there's a small one there. That small one is not necessarily any less powerful than the big one. It's quite possible that it has more power, especially if it's newer. If it was me, you could say that, but I don't think I'll be marking the exam. Yeah. The way I mark is you know, if it makes sense, then you get to mark. You know what I mean? And I think you'll find that most teachers mark that way. I would be surprised if they didn't. Okay, so I think you'd probably be all right. Yeah, computer case. Yeah, I mean, but yeah, you never know. I won't promise you, but yeah, I hope. So yeah, so external hardware is going to be outside the case, if you want to call it that, your computer case or your system unit. And we often refer to that as peripherals. Peripheral means outside or on the edge. And yeah, so not going to get too excited about those little definitions. They're okay. But yeah, so obviously these things here are all peripherals. And the other thing that we notice about these peripherals is that they are input and output devices, but they didn't have to be. You could have a peripheral storage device, which would be your external drive, which would be a tape. Well, I don't know, probably be a hard drive. So some other nice things that we've got on there, the power supply, very important, the power supply, because the power in the walls is not suitable for a computer. I mean, it's 230 volts, which is AC cycling at 60 hertz. So that would be damaging if that got anywhere near the motherboard. So we actually take that power and we convert it to useful, which would be 5 volts, which is a lot less than 230, right? So it needs to be changed to 5 volts because all of the motherboard and these components here, they run on 5 volts. If you're using a laptop, some of that conversion will happen in the cord. You'll see there's got this little block in the cord, right? And that's going to be converting it, not necessarily to 5 volts, probably it'll be like 19 volts or something like that. But then there's another little unit inside that converts to 5 volts. Everything happening in here is 5 volts. So yeah, so what do we got? The main thing there, that little block in the in the middle of the, it's not in the middle, is it? But sort of central in the motherboard is the CPU. There's something missing from the top of it, which would be the fan. CPUs have fans on them nowadays because they produce so much heat because the processing that's involved there is using a lot of energy, produces a lot of heat. That needs to go because heat is damaging to all of these components. And so you'll find that people will tend to have an air-conditioned room for using their computing. And also that they will, if they want their computers to last, they're going to make sure that the exit vents where the fans are not blocked, so that there's a good free flow of air going over all of those components so that they don't get too hot. And as I say, use it in an air-conditioned room. So the VGA card, let's take each of these. Should we start there? DVD-ROM drive. I don't know if I'm even going to talk about that because that's like so last decade or last century, right? Is anybody using DVD anymore? No, we're not, because everybody's doing everything in the cloud, right? Because we all have some kind of access on the cloud. So I mean, if you've got a Microsoft account, you're using OneDrive, or I mean, you're storing your stuff up there. You're watching Netflix instead of DVD movies. You know what I'm saying? You download your software from the internet. So what do we need DVDs for? I don't know. I haven't used a DVD for a couple of years. Maybe you do use, but if you've got fast enough internet, you're not going to. I don't think so. Somebody's going to tell me. All right. So where would you use it? If it was a DVD that you could write on, then yeah, you could use it to back up your data. That might be good because you can get a lot of storage on a DVD for not very much money. So I'd use it maybe as an external one. CPU, that's the processor for your computer. So often they're made by Intel. There is another companies that make it, AMD. The CPU fan I mentioned. The RAM, that's the random access memory. That is going to fit into these slots here. And one of the best things that you can do to make your computer faster, well, two things: you get a faster processor, but also add more RAM. Once you've bought your computer and you've chosen your processor, if you want to make it a little bit faster, one of the cheapest, not cheap, easiest way to make it faster is to just add some more RAM. Nowadays, of course, people are using SSDs, solid state drives for their secondary storage. So they should be kind of fast anyways. VGA card, why would we use a VGA card? If you look at that, we'd see another fan. Why we got another fan there? Because we got another processor there. Got another processor there because that is actually like another computer sitting on your computer, I guess you would say. It's got a processor. What it's doing is it's processing all of the images and imaging that's going to be going on your computer. That's really important if you want to win at video games. So we like to play at video games, but if you like to win, you don't like to, as my daughter would say, lag. You don't want to lag, right? Because then the other people, if it's one of those action games, you would be caught out. So you want fast as you can get, and so you'd have a VGA card. Sound card, same thing, want better sound. You can add a card. Now, when I say that, you could have a basic computer without those, and you would have video and audio components built into the motherboard. And your laptop has that, right? But if you wanted to have, if you've got a box as computer and you wanted to make it be faster in a game, you'd add more RAM, you know what I mean? Maybe you add a faster CPU and maybe add a better VGA card. Or when you went to buy the laptop or buy the system unit, you'd choose the option which was more powerful. Hard disk. I just mentioned that we use SSD, solid state drives. This hard disk here is representing the hard disk with the spinning platters in the middle. That was the way that we did secondary storage for, as I say, for 50 years. It seems to be going out now because I guess the SSDs are getting cheap enough that people will use them. But you still can buy hard drives. It is cheaper than an SSD. When I say cheaper, like terabyte of hard drive is going to be a lot cheaper than an SSD of terabyte. But you can get a terabyte on your blinking Samsung, S22. I saw that in the specs. Terabyte of data. I mean, that's not going to be a hard drive. You know, that's just gonna be a
Terabyte of space.
terabyte of space on the
That's one.
S22. I saw it. It's like $1,500. So, oh, for the S22. Okay, so again, back in the days when we had digital cameras, you know, they had special cards that went in the camera, and that was a storage device. So you'd have to have a special reader. Yeah, I think people are using these for their cameras, unless they, I don't know, unless you're a really, really fancy photographer. And then that goes straight to the cloud, right?
Yeah.
Awesome. It's so good to live in the 2020s, you know, get rid of some of that clunky old dumb software. I mean, hardware. All right, so here's some peripherals that are input devices. I got a webcam here so I can record. There's one there. Scanner, yeah. Mouse, joystick. Anyways, microphone. The motherboard. See the big hole in the middle there? That's where the CPU goes. Now the motherboard has what we call a bus on it. The bus, like if you come to work on the bus or to college on the bus, you don't come by yourself, do you? You come, there's lots of seats on the bus. Lots of people get on that bus. And that's the idea here, is that you have parallel wires, I guess you could say, built into the motherboard that transport not people, but transport data from one place to another on the motherboard. So that's your bus. So the CPU is going to be communicating with all the rest, other parts of the computer on the motherboard through the bus. There's actually more than one bus, and the speed of the bus is another thing which will contribute to the power of your computer or the speed of your computer. Unfortunately, you can't upgrade that without changing the motherboard. So when you buy a motherboard, you'll check and see, oh, is that got a fast bus on that? Yeah, okay. And so, but you can replace the CPU, sort of fit into the slot there. So there's the bus. And memory we've talked about. So the bus, as I said, there's more than one bus. And so the fastest bus is going to be for actually the memory. And so you'll actually find that the memory is going to be kind of close to the CPU. And that's important because that you need that. If you want your computer to go fast, you want to have the communication between the memory and the CPU as fast as possible. One way of doing that is have a faster bus. Other way of doing that is keeping it nice and close to the CPU. So that's what you've done here, as opposed to these other peripheral things, which are a little bit further away from the CPU. Okay, so some output things. You know, with the plotter there, what would really be cool is if it mentioned also a 3D printer. Have you guys heard of that? Yeah. So with the 3D printer, so you can actually print parts. You know what I mean? I don't know about metal parts, but you can print hard plastic parts. So yeah, so we are sort of getting into some pretty cool things nowadays. Most new cars now have an option for GPS built into the car, right? Most new cars are now, yeah. If they don't have that, they have an option for you to Bluetooth link to your phone, and on your phone you got a GPS, right? I mean, you just use Google Maps. That's a GPS. So what's there? Yeah, we have touch screens. The technology is so much, as I said, 2020s. You guys are so lucky that you got all that cool stuff coming in the future, I suppose, because it's pretty cool at the moment. Who uses this? USB. You still got them? Yeah, all right. Okay. But you don't use this, do you? Hey, we used to store data on that. And I mentioned the DVD. A ROM chip. Now, the thing about the ROM chip, that's another form of memory, but it's read-only memory. It's not memory that we can go and sort of change without doing some sort of, you have to remove the chip. RAM, I've discussed. Hard disk. Can you see the platter that turns? This thing sticking into the platter, that's the read-write heads. In the back in the day, we used to talk a lot about that, but as I said, we're not really using them much anymore. So we call this a floppy. Anybody use any of those? No. Right? I mean, I don't know. They maybe held a megabyte of data or something like that. We could get 8 gigabytes on this, and you can get bigger ones than that. So memory cards, yeah. you'd put those in your mobile phone, I think. What do we got here? Network interface card. Okay, so for networking, communication devices. So the network interface card, the thing that you might recognize is there's a Ethernet or RJ45 connector port here. So do you see that? Now, when I say Ethernet, what I mean is I'm talking about is that it? That's, yeah, I think this black, no. Where's my Ethernet? It must be that. It's got to be connected to the box. I don't want to disconnect it though, but yeah. The Ethernet is the cable. If you might have this at your home, might be connecting. Yeah, if you've got Irido fiber coming into your home and you use Wi-Fi, there'll be a cable that will go from the box on the wall to the thing that stands up, and that would be an Ethernet cable, which will have a plug like that. So Ethernet is your standard networking sort of protocol. I mean, all of these computers would be connected with Ethernet. It's kind of faster than using Wi-Fi, and so that's why we would use it here. But this is access point transceiver. This is for Wi-Fi. We do have Wi-Fi in this room, so I think there's one there and there's one. This is what we call an access point. And if you look at it, it says Cisco. And so it's really a radio, as it says there, it's a transceiver. So it transmits and receives. It's sending out signals. We're not using that for our desktop computers, but anybody who's connected to Wi-Fi on their phone is communicating with that. And of course, all of those communications are secured. All right, there's a security on it at a certain level, I guess you could say. Now, these things here, I think most, I don't know. I was going to say a lot of computers are going to have that built in. That network interface is going to be built into the computer. So it's just going to be you'll see the port there, but it's actually built into the computer. This one here would be for really old laptops or something like that, where you didn't have a laptop that didn't have any connection for a Wi-Fi. But nowadays, laptops, just like your phone, they got Wi-Fi radios built into them, right? Your phone's got, so what radios you got in here? You got at least 2 radios. Well, 3, I guess, if you call it one that connects from the cell tower. Well, what are we picking up on here? I'm picking up GPS signals, right? So that's from a satellite. The satellite's sending out a beep, 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 beep. What thing is, it's not one satellite. There's like 30 of them or 40 of them or 50 of them, depending on where they are in the sky and how long it takes for that signal to come down. And that signal comes down with a timestamp on it. So depending on that, there's a mathematical triangulation goes on in the software here and tells me where I am. That's cool. So I got a GPS radio in there, antenna, and then I've got a Wi-Fi one, must do. And then I have a Bluetooth one. And then I have a receiver for the cell tower as well. So there's a lot of communication going on here, right? I mean, and that's tiny. I'm holding it in my hand. Now, it actually looks bigger than it is because all of this is this metal stuff that I put on mine because I keep dropping it and breaking it, and that stops it from breaking. It doesn't stop it from dropping, it stops it from breaking. Okay, so system software. For most of you would be familiar with Windows, right? That would be the system software I think that you'd be familiar with. However, as I said, I was talking about my phone. This has system software in it as well. From time to time, you'll get a little message come saying, there's a new version of the Android software, and so Android software, and you'll update it. Now, some of you might say, I'm not going to update that. Well, I always do. I do it like the minute it comes. And the reason I do that is because what happens is there's lots of people trying to hack the systems all the time, right? And they're trying to hack your phone. They're trying to hack that operating system. And sometimes they do. They get a hack. And the companies don't always tell us that there's been a hack. But what they'll do is they'll get their engineers onto that and they'll patch it. And when they patch it, they have a solution to the hack, all right? Or they block the hack. And so they'll push that out as a new update. So I always take it because if I know that if I don't, I might be, I don't know for sure that this will happen, but I might be vulnerable to somebody hacking me, and I don't want that to happen. So I want the latest version of the software that's got the latest security in it. So yeah, there's the operating system. I mentioned that one was the Android operating system. The other one you'd be familiar with would be Windows. When I say familiar with, I mean you've been using it. And some of you might have been using Linux, maybe. So as it says there, the operating system must be running before we can do all the other stuff that we want to do with the computer. And the first thing that happens when the operating system starts running is it must boot. So we say boot. It's kind of, the idea is from pull yourself up by your bootlaces. So we say we bootstrap or by your bootstraps, which means to start from nothing. So booting the computer is to start from nothing. That is where we load in the very small kernel, the very small starting bits of the operating system, which then loads other parts. Loads where? Loads into the memory, loads into the random access memory. So when the computer's turned off, or the phone or whatever, then there's nothing happening in the memory or the processor. Yeah, so we use graphics in all of our operating systems. There's some of the operating systems that you might have used. Windows iOS, which is Apple, Linux, and Android. Okay, so here's some different types of computers. Embedded computers, like the self-driving car. So what do we mean by that? The self-driving car, why is it embedded? The car is not a computer. However, the car has computers in it. Those computers in the car are embedded. Does that make sense? So, and there's actually more than one. Mobile devices. I love mobile devices as computers. I'm waiting for the time where I don't need my laptop. I'm just going to use this, right? If I could get good enough at it. But yeah, you can do a lot on it. You can write computer programs on that if you're, I don't know, if you're better with your fingers than I am. Servers. So yeah, this is going up in how you say, the thing about servers is they're usually not for a single person. Servers are going to serve multiple users and multiple systems. And so that's why we say mid-range. So they'd be involved in a network. We have a bunch of servers down in building 3. If you look at there, I don't know if we noticed that before. Do you see that little thing there? That box? It's got a bunch of wires going to it, cables going to it. And if you looked inside, you'd see some devices. Those are actually a bunch of switches. And so the switches, what they do is they're concentrating the communications from this room. And then that goes by a fiber backbone. Because if you looked inside, anyways, on your way past, sometime look at it, you'll see a bunch of white, thick cables. Those are the Ethernet cables that I was talking about. And then you'll see some skinny yellow cables. The skinny yellow cables are fiber. And so we've got a fiber, what we call a backbone, which is going to take that communication down to a room at the end of this hallway, which is then going to communicate to the data center in building 3. Mainframe computers are used by large organizations. Well, I guess that makes sense. So nowadays, yeah, mostly that would just be like banks and stuff like that. A supercomputer, the fastest, so used to be in Australia that we had one supercomputer and that was run by the tax office. Well, that makes sense, right? I don't know who's got supercomputers now. Anyways, any questions?